Let's start. Yeah, this is my honor to introduce my old friend, Dr. Boris Farber. Dr. Farber has authored more than 1,000 inventions, books, publications, and presentations all over the world. 1,000, fantastic number. His pioneer inventions are based on TRIZ, including self-adjusting and self-organized dynamical systems in many areas of bioengineering and biotechnologies. He was named a professor and scientist of the years 2010-2019 in the United States. He received medals and diplomas for his inventions and scientific contributions, including merited inventor Leonardo da Vinci, Nikola Tesla, Leibniz, Euler, Gauss, Koch, and Ehrlich. Dr. Farber began his scientific career with experiment planning to implement Da Vinci's model of diverse education 55 years ago. Dr. Farber applied these to Da Vinci's legacy, which helps better understand the legacy of a great genius and together with Dr. Amner has been writing a book and a script for science fiction movie devoted to blind spot of Leonardo da Vinci's work. Please, Doctor.
And nodule is backward of legion. If it is backward, so the nodule. Why you choose it? Because these bacteria, they fight by legion of our guts. This is a from Bible. So question for this community. Would you like to follow sequential continuous function history of my diversity ideas development? Yes. In this presentation, I apply classical TRIZ plus my own reason, not necessarily on the publication of theories. And the second, you could ask question at the end of my presentation, not interrupt flow of explanation.
I'm great.
So that's good. So in this presentation will be mixture. Versatile or life strategy with different our application for TRIZ and some of our methods. Lab strategy. Two main events occur in chapter. The first one was a present I got from my parents for my 10th birthday, a collection of books, diaries, along with replica, bas relief, and coins dedicated to Leonardo da Vinci. And the second phase I introduced to TRIZ. These events inspired me to want to understand the legacy of Leonardo da Vinci from different perspectives, including TRIZ. I want to say that father was inventor. He is a Green Beret, and he invented gun machine many years ago. After his invention, he contacted for publication in magazine on the cover. You know who's it? Kalashnikov. Yes. He contacted him, and many years they contacted together. So he decided to be a professional inventor. He created many different technologies. Some of the technology maybe we create together, maybe I represent next time. This is TRIZ specifically in logistics, which brings $1 billion per country, billions, in logistics. But since this today is out of scope, I will concentrate on topic related to this stuff. Why he introduced to Da Vinci? Because this was many years ago, he followed these ideas related to this. So, I use, to go in the depth of this problem, I use Ishikawa diagram in my vision to see, actually I use a few times. For this particular project, I use it understanding fields where Da Vinci worked and base of knowledge he applied to his invention. And the second Ishikawa diagram I used to analyze his inventions itself. A little bit small, understand, but otherwise it doesn't fit. So all these inventions, what was he made in different fields and projects, I combined together. Based on this, I just give you facts that stood out to me. The first, Leonardo da Vinci displayed top skill in a unbelievable number of diverse areas. Being the greatest scientist and artist of masterpieces, he admired that the human foot is masterpiece of engineering and a work of art. For me, it was a little bit strange. After Mona Lisa, a human foot, right? Masterpiece. So I was very curious about this and would be the next step up. He made discovery of the wave nature of light. He had great impact of nanotechnology, geology, hydraulic bridges, etc. He used nanotechnology for his techniques for motor, in painting and that type. Created the first robots, a self-propelled car, multi-X tanks, and many of the greatest inventions in various fields, 500 years ago, even more, 600 years ago. Hypothesis: all of Leonardo da Vinci combination of fields of knowledge chosen by the genius himself were not random at all. And this particular combination of fields of knowledge and their order would have unique synergistic effect for creativity. It's according to our life strategy, or the STL like we used originally. We have to choose a goal. And after that, I set goals based on these Ishikawa diagrams, on all this analysis. Goal number one, analyze fields of Da Vinci knowledge in the first Ishikawa diagram. Analyze his project and inventions. Based on this analysis, get a deep knowledge and education in all related main fields, especially biomechanics and bioengineering, nanotechnology, to study entire Leonardo da Vinci scientific legacy, to study relationship between various fields of Da Vinci science and art. Study supplementary fields would help to get main ideas, main fields, according to current level of knowledge, 21st century. And try to, based on these 6 items, item 7, try to understand inconsistencies and blind spots in Da Vinci legacy. So, skipping a lot of steps, I start from this step in education about human food. Again, this is his aphorism about the human food is masterpiece of engineering art and a work of art. So, to be very curious why it works, after getting education in 4 different universities, I decided I choose postgraduate school for Central Research Institute of Prosthetics. It's the biggest institute in the world in this field. They study food. This is great institute, and the first topic was artificial food. Why I came here. If you remember, descendants of modern prosthetics were very not anthropomorphic, private level. No science behind it before. To analyze a problem, I create well-known matrix, past, present, future. subsystem, system, supersystem. And this, we have this system which I decided to study artificial food. It was a subsystem of global prosthetics and supersystem man. In addition, if you go in future, artificial food supposed to be more functional, supposed to have more control and recuperation to save energy, if you look in this direction. And if you're talking about prosthetics, it was supposed to be with external energy sources and increased functionality. Why? Because after amputation, person loses muscles, which are source of energy. And after that, add one more column here. I always do like this. IFR. Why it's important? You have to understand target where you have to approach. In this particular test case, for instance, if you're talking about food, it's supposed to be advanced treatment, the regeneration of teeth, and avoid amputation in future. If you're talking about person who would be maybe cloning, a level of medicine is supposed to be much different level. So studying this three-level diagram, 5 squares, I moved to the next one and decided to use synergy combination of TRIZ with biomechanics and bioengineering. In this particular stage, before to start creating something new, I use my favorite expression of Max Planck. An experiment is a question which science poses to nature, and the measurement is the recording of nature's answer. You have to measure before to create something, measure parameters. And unfortunately, at that time, not all parameters you can easily measure. And I start my project with studying elasticity system. We created a patented system for measurement these devices, which help us to understand viscosity, elasticity, all elements in sagittal plane, frontal plane, and transversal plane, all planes, three-dimensional. So get set of data, and if you see from this picture, this is a static system where you put here load and study a placement and relationship like Book law, for instance, if it's elasticity system. Replacement and like a function of load. But next, suppose according to TRIZ, next supposed to be dynamic system, right? Because food created not only for standing, basically for walking. In this case, I created simplified system of dynamic system, where we created impulses here. You see from this one, dynamic impulses, and studied from real. It was very important because nobody did it in rheology. You know different rheological models. For instance, Kelvin flow or Maxwell element, which is combination of elasticity and viscosity. And combining of this, only in this case you can adequately modulate muscles, model muscles and process flows. So this is dynamic system. It after creating it was widely used in the entire industry. And next, it was difficult to get elasticity food. It was not classical beam. It is a very complicated shape. So for this case, I use a method for the elasticity. You know the idea of this. If you make a model of this, I use polarized light and make apply force. You can easily get tensions over there by isoclines. Let me show this one. It looks like this. And we have special method how convert this to particular stress and heat. Why? Because feet is broken. Nobody knows why. Now when we can count, it was very difficult. We use also the method of finite element, very popular for this case. Together with, you know, this airplane company, MiG company, who created military plane. We made some projects together for finding out using the method of finite element of the stress and behavior of this complicated system. Based on this, after this measurement, we created a few patterns. Right side, we see, you know this from Da Vinci. He studied thoroughly this book. And this our studying, biomechanical studying in this artificial field. We get two patterns of this. And when we produce in industry, it was a food advanced functionality, and this was another thing also in this case. So it works for any level of computation, below knee, above knee, and even hip disarticulation. It was difficult to figure out behavior of viscosity and elasticity during the gate process. So for this, I spoke at the time with a friend of mine, Boris. He developed this anticipatory failure determination. It was not published yet. And what we did, we created special prosthetics where you make diversions in this case. We change elements in patient and measure few parameters. First of all, we measure ground reaction in sagittal, frontal, and transversal plane. We measure momentum. We measure ground displacement of center of gravity. And we measure angle between joints. When we change parameter deliberately with what's beyond of range what we expected, we study how anticipatory failure determination had impact on gait. Because many people, unfortunately, they don't know mechanics who work in this field. And they put sometimes parameter of, I give example. Everybody has shoes, right? But how you buy shoes? By size. But one person is 200 kilograms, the same size, another 60 kilograms. So the dynamic absolutely different. Based on this recommendation, we found ranges for each kind of patients, and we publish it in #1 magazine in Journal for Rehabilitation, Research and Development in Baltimore. And many people use this relationship. Now, after studying a subsystem, artificial food, which was my goal, I moved to a super system in man. Since we study, remember this hierarchy, nine rectangles, right? People. And next, I was very curious when we started. We made a lot of experiments with biomechanics of man, physiology, etc. And after that, since one of my target was Da Vinci, I get this information. I read only this book one, where I found that he had the first stroke, which caused right hand paralysis when he was 65 years old. The other stroke events then followed, deteriorating the ventricles and motor activity. And as a result, he died with this. This is one of the reasons including sources, is stroke. But stroke related to biomechanics. And since we studied food, our goal was to apply this knowledge to fight somehow strokes in this case, to help the patients. And what we did, if you see recommendation of doctors, if you have limited mobility, exercise. So there's contradiction. In order to recover faster, patients should do mild exercises, walking, but he can't walk. How to walk without walking? You do exercise with the spine somehow, But how to work without working? Is it possible? Well, if you look at this next slide, we study knee angles. Actually, not only knee angles. We study three-dimensional movement. I just demonstrate here knee angles. And ground reactions. And pressure displacement. Okay. This here, this. And we know, if you see topography of this pressure to the dam, right? If you see the next slide and compare foot localization of Pacinius corpuscles, you know Pacinius body. But what a Pacinius body is vibroreceptors. Without this, you can't feel vibration. So many people, they think this food is just a piece of material which helps you walk. No, it has a lot of other Pacinius body as well. If you look at this localization Pacinius capsules and skin, it looks like this. And if you look closer, you will see this Pacinius corpuscle that we study a lot. But we made a lot of research in macro level. This is Pater Pacinian corpuscle. And if you apply force to this force, to corpuscle, right? You get some impulse over there. And we have diagram which shows how this receptor works. A relationship between force and reaction of this particular receptor. So how to apply this knowledge further? Principle 18 from our famous 40s principles. Mechanical vibration. I like different cartoons here. We haven't yet found what causing the ringing of the gears, but we were able to set them to vibrate. And we decided to set them to vibration. Okay? Well, we created a technology, and this patent technology of imitation of walking and running for rehabilitation of patients with various movement disorders. This is our patent. We made a lot of research which can fit this small presentation before. And many of this was not published at all because we will see in a few minutes why. And this particular way is samari cobalt magnet, and this is magnetic wires, electromagnetic wire. And base this, we put this in matrix, and we have system of control, and we created special shoes based on this. Shoe was adjustable, dynamically adjustable by any size, like this. And you can recognize our vibrator here, right? It moves for any patient. And I will tell you a few words about how this works. We have a special program. The first devices were like controller, it's not computer yet, right, at that time. And our signal was synchronized with spaces of gait, with 10 space. We have heel strike, whole foot contact, and two off, right, this one. And vector ground reaction moving like this along with this foot. So based on this, we try to study, it's not just massage devices, no. We created reaction, we created impact on these receptors again, according to phases of gait. And person, he felt that he is walking, he is not walking. He was lying on the bed, even breathe faster. I can walk so fast. But he was on these shoes. And this method was implemented it was so successful, is implemented in force clinic, in government clinic, only for government, they all use. Short problem, many years. After stroke, after heart attack. They move and they don't move. There is contradiction, yes? And you can compare EMG and Doppler blood before and after, you will see significant difference, right? Of this. And level of signal is pretty small in this case. What we did next, we study the biggest surface of organ in our body is the skin. But people don't use vibration at all. They use you know where, and they use a cell phone, that's it, right? But this is the most powerful way of transmitting signals, a much more efficient than vision signals. And we made experiment. We take military planes, and we put pilots which close eyes were closed, and they have vibrational joystick. And they're supposed to land this plane. It was targets on the pavement, and they're supposed to land close to the target. Possibility to land with vibra is much faster. Accuracy was, and the result was much better than you plane when you use your vision. People don't estimate enough this way of research. So we work a lot, and I give you some example of this one. This is pilot cabin. It's also our pattern with joystick, all this stuff, and special signal transmitting. And we use it not only for plane, we use also for cars. And we use it in space. So all spacemen, this particular Salute 6, you know, this space project, right? All of them use these devices. Why? Because gravity is supposed to move. And they can move. This excellent opportunity to apply these devices. We give them impression of moving without moving. And we use it a lot for pilot who, let's say, from Moscow to New York, or Moscow to fly from Moscow to Vladivostok, many hours in cabin, they use these devices. We use these devices for operators of nuclear stations. They're supposed to be aware. If you forget about this, forget about the city, right? If you don't press, not react in particular case. This is idea of one of these very productive direction from my point of view is related to food. And this small joke, first the baby shoes and baby feet, and as the years go by, all kind feet. So other than food fields of applications. For instance, when we created this, we contacted a society of blind, deaf, and mute people, and they asked you to create something, because if you know this kind of Olympics for them, right, for these people with disabilities, and they can't run because they can see something, they can hear anything, and usually in front of them some person running and holding hands, and they run together. So it was our project. We apply our system where the trainer was sitting on the tribunes, right? And he controlled. When it vibrates left side, it goes to left side. It was like miracle. It was a world competition. And this team, they ran without anybody. All stadium was moveless in this case. Blind, deaf, and mute people in this particular case. Because vibration is beautiful, not necessarily to see, even more powerful. And we produce these devices for this society. This is later, I have a presentation about this in Florence, I'll tell you later. Where I make parallel with analysis, remember, Ishikawa diagram related to Da Vinci's and all this stuff. I make parallel fields where I apply my knowledge, similar to this. So this conference will be in June 1619, and we celebrate 500 years of Da Vinci in this particular case. Now, for instance, based on our understanding and studying different directions, I graduated from 19 different institutions, 99 postgraduate and different. And one of these was application. I was curious how to create a car with new function. And you see this is part of a car. This is right. And usually when people create a car, they have limitation of load on one axis because pavement breaks. It's like a standard. You can put more loads for one wheel. What we did, study our wave mechanics. We studied stress distribution. We built a big car which moved around 100 meters day and night, put different sensors in pavement, and study distribution of this. And based on this is stress distribution. And what we did, we control, if you remember, this is dynamic car. We control distances between these elements. And one extension and tension, they kill each other. So in this case, you can carry 30% more load without any problems for pavement. Can you imagine 30% more? Because in this case, it's like idea Dr. Klein showed in monobipoli. He showed concrete. It's idea steel works for extension, and concrete where work with compression. This was similar idea. Extension killed by compression of another wheel. And you can easily regulate this special device. You can regulate distances between these. So, and we were inspired this by fields of Vinci. One more example. He studied a lot of bones in his diary, and we have problem with bones. And you know, when bone is broken, or sometimes one bone is shorter than another bone, right? We created together with, I work with, if you know this name, with Elizarov and Kalmbers. It's Riga, Latvian Institute of Traumatology Orthopedy, located on Dundas. So we created this one device with self-adjusted. You know, idea of compression osteosynthesis. Should I tell a few words? Idea is, if you have two pieces of bone and you make compression, they become some substance here. You have some substance, and it grows faster under stress. And after that, you can move and make distances bigger and bigger. And finally, your leg can be few centimeters longer. And second one, when you have problem with trauma, your way of recuperation was much less. If you remember, it was famous jumper, Valery Brumel, Olympic champion. He was treated because of these devices. He won Olympic Games. It's not our participation, the same idea. Right? And we work for different orthotic devices. It's also, all of them is our patents. They're also widely used. Okay, when they have problem with this part of neck. And this is cartoon. So remember, I came to this institute with plan A to study food. Like I promised to do exercise every day. But finally I came up with plan B. Just watching it around changed my mind, right, on experiments. So in this case, just emphasize, my plan was to study a subsystem, a food, but using system operator. I moved to a super system, a man, food control, and decided to move to a sibling system. I use object-oriented programming terminology, which in class classification the same level, hierarchy of classes. But another subsystem needed serious design, because when created prosthetic devices, food is not enough. You have to think about the entire system. When I studied after that, I created the same system operator for different object. This system operator for about knee prosthetics. And you see our subsystem is knee unit. And we see this hierarchy: subsystem, system, supersystem, past, present, future, and ideal final result. So when we started this system, I was very surprised. And you will see why in a few minutes. In addition, I understand where it's supposed to move. Very good idea of this system operator. Always useful. Dr. Klein today explained many results, but behind of them we use each of these results. We use it in order to save time. We don't show this, but each of these three, somebody asked about TRIZ application. We always use this operator, all the stuff that I show in this my presentation, all of them. Because TRIZ is TRIZ. We show only principle. Behind the scenes is our approach, not necessarily all stages we describe here. We don't publish all of them. And after that, I created inheritance of system. Again, you're familiar with idea of inheritance in object-oriented programming. It's basic idea of classes for today. Very productive, right? And each class and superclass inherited all feature of class, subclass of class has given of his own. Based on this hierarchy, this arrow shows parent-child relationship. This is child, this is parent, this grandparent, we're talking about this here. So I try to put in this system this new element. For instance, we study artificial food. Now we have subsystem, knee unit. And after that, another element, the hip unit, because some hip articulation is supposed to create also hip unit. And after that, we analyze all different possibilities of this one and created class, superclass for them. We don't publish not all these elements in order to have more readable of this. But our super system level class 1 map has subsystem artificial organs and these artificial limbs and other artificial systems, upper limb prosthetics, lower limb prosthetics, orthotics. For instance, upper limb prosthetics. In our institute, we created the first myoelectric hand in the world using this approach. So after that, we sold license to United States. Now they produce in Japan, but the first was created in our institute that I show. But this beauty of this hierarchy, when you see of this, you see another way. Another branch of this super system class C is medicine, diagnostic drugs therapy. And why we do this? Because later you will see, in many cases, you're not supposed to make computation. If you use nice, for instance, class, if you have nice medical drugs, not necessarily cut this food or knee, etc. So simultaneously we study all the system, and this few example of our project we did for medical drugs I'll show in another presentation. And this we work for all this element of this subsystem for artificial organs. If you go to the next step, and you will see analyze cause of amputation. You see diabetic and gangrena take 71% in vascular disease, more than car accident, not compatible even. So definitely we're supposed to develop way of treating this disease. That's why, before the go further, we decided we created Ishikawa diagram for analyzing all knee mechanism and found nice relationship here. We have swing phase with our leg moves like this, and stand phase we use stand. Instead, and we have related to these functions, we have different devices. And for instance, for swing phases, majority you have to move your leg. You have classification amount of axis, and this is wrong configuration of this. Many different disadvantages for this one. Extra forces. The second is strength and durability, and work resources. Work resources of these new units was very limited. They have limitation. They can put heavy system for patient who lost his legs. It's supposed to be small, light, and durable. All of them were broken for some reasons. Plus, from my side, I give example. This is function is supposed to be kinematic similarity, and they have all the prismatic slider pair you will see in a few minutes in our drawings is self-adjustment for rate of gait. Rate of gait, it's very important because patients moving with different rates, we do without thinking about this. So we created levels of obstruction on the units, and with base front links, if you have mechanical units, back links, guide tube, load, springs, strength mechanism, 5 classes pair, and dissipative element, friction, hydraulics, polymers, and magnetic rheology. Based on this, and I published few, I just found this application, this was 84, when I make in Novosibirsk, it was publication 84, where I created mathematical model to get this functional, and we use our S-curve classical Altschuller's S-curve to analyze our patterns and use this functional of energy cost, how to analyze this pattern results, and make some prediction of this. This was the first publication, and second was in the same. I proposed at the time the first moving from not from macro to micro to macro level. Why it was important at the time for prosthetics? You can create any physical effects, but patients supposed to walk and walk very durable. In this particular case, I created a method. We discussed with Gary Solich what when he proved, I published. And if you remember this famous #1 book in the world about, I'm not talking about, well, everybody knows creativity is like science, I'm talking about Dr.Boris, 6-volume books about all mechanisms in modern engineering. People can't use this book. This is a bunch of information. I created a few using kind of like standards how to move from micro level, let's say pointing effect, to macro level, from micro to macro. Based on this, this is part of these references. Based on this, we created a special method, functional analysis of the most typical view. So we analyze this uniaxial balancing weight for bar knee mechanism, the most popular in the world, and cause and effect what we use here. For instance, I will show more in more details after that, maybe return to this problem, how they work physically. The second one, it was structural, functional, and mechanical method of improving the system, prosthetic, orthotic environment. So we see many elements of TRIZ we use here, starting from studying functional oriented search, the mechanically functional and mechanical properties, structural synthesis. This is specific part of which we use for creating new robots. Parametrical synthesis, functional interfaces, technological devices for assembly. And after that, we use transition from micro to macro, back and forth. We see this in back and forth. And we apply theory of rational mechanism. I have never seen that anybody in the world from TRIZ knew this predicate who cared about this mechanism, rational mechanism. The absolutely outstanding theory which was created one of my, how to say, teacher maybe, one of teacher, Professor Reshetov, Leonid Nikolaevich, become friends. When he was shown, when he got a new reductor created in Siemens, when he looked at this, he immediately said it does not work properly, immediately. He had special approach. And nobody used this theory from TRIZ at all. When I did it, I explained what is advantage of this. So after that, we used biomechanical research on the spectrogram, electromyogram, support reaction, sheet kinematic dynamic muscle work, and interlake angles, right angle, we use gyroscopes for this, and all this stuff, anti-failure determination. So all the system, if you use only this part of tree, the system does not work. You can create, you have to know this one. This is not a system. This very small part of the system. And when we go to the next slide, when I studied all this mechanism, I had impression. I would have written a shorter letter, but I did not have the time. Pascal, remember this expression? Not the story need be long, but it will take a long while to make it short. So people created different devices independently. They are not connected to each other at all. I give example. For instance, this is new unit. Simples, more durable, and this one axis here, you see one X goes over there. To make stability, they put this axis behind. It's stable, but when you move your leg, this one of the devices, you see what happens when you move your leg, and second you get scoliosis. So all people, in addition, why? Because it's short. When you move it, toe touching the ground, you can move it. So what they do your leg shorter, simple medical way. And after that, person going over this life like this, with this device. This one unit. In other devices where they put even lock for durability, but if you look at the system, trajectory of movement you see trajectory moving in swing phase, it goes under the ground. Only one way to make it work, make it short. A lot of energy plus scoliosis. So, and this is a special device where you can move all this, make all this trajectory movement easily. So that's why we created a model for swing phase, analyze relationship between location of knee joint and the functional length of this in swing phase. After that, we study this from point of view of pendulum, because trajectory is one question. The second is dynamics. The leg supposed to be anthropomorphic movement, and second, symmetrical. You will not have a patient who would like to have one leg from one side and wheel from another side. They want to have it symmetrical. And for this, very important to study equation of this pendulum and study position of moment inertia to make this symmetrical movement. So we studied two parameters for swing phase. After that, they found another beautiful unit. Remember? So person losing muscles. And we're trying to get this, the prosthetic, the lighter the better, right? Because he doesn't have sources of energy. But guess what? They produce another prosthetics. First of all, is one axis knee unit with which move back from line of symmetry. And second, they put a load over there from 500 grams to 1 kilogram. Nice solution, huh? This produce it. Why? They want to improve this movement in this case, because like in swing, moment inertia is supposed to move back and forth. And during moving, this moving back and forth. Either this one, we have extra links over there, or this one, this flexible, and this how it works. Whatever I give is not a project, it's from a serial production of plans for patients, right, who use it. They're very happy, they move nice, and carry, can you believe, every day from 500 grams to 1 kilogram extra. This is how it looks. You see this float over there? So the first was one axis new unit without float. Second is one even better with low. Okay, to improve mass inertia parameters. And I studied parameters of stand phase for stability. Why they move this axis back? Because you have to be stable to put your leg in stand space. And force supposed to go beyond of this point rotation. That's why you went to dynamic and created mathematical model of gain, because you have to combine swing phase, stance phase, and energy cost. For your energy cost, you can go to a special device and see how much electricity you spend, right? I will find the energy cost for patient. We have Lagrangian model, this one, with all these angles. We create a few mathematical models of this, and we count energy cost. So created this Lagrangian equations. I will skip it not for this. This is stick diagram. What we found that energy cost really depends on location of knee joint. So sometimes you have optimum, sometimes you have a lot of energy wasting for nothing. From this we have optimization. This is our functional of energy cost. This is momentum, and the first derivative of angles, actual acceleration in joints, in ankle, knee, and hip. And definitely in this model, you put all mass inertia parameters of patient. That's why people invented another mechanism, 4-bar, 4-axis knee mechanism. In this particular case, your movement much better. This movement in stick phase, right? They use special way of synthesis. And you can make leg equal length to intact leg, right? Which you have. And we studied different elements of this, and we improved this knee unit in this our pattern, and this works much better. Because for now, trajectory is 4th degree trajectory of movement, and you can make it equal to intact leg. But what is the disadvantage of these angles? Disadvantage: more elements, more axis, less durability. Every day you walk 10,000 times, let's say 10,000 steps, maybe less. As a result, they have noise in these joints, and system does not work properly. All of them less durability, obviously. More element, less durability, right? What to do? In this case, we are the first in the world used with prosthetics. I'll tell you how I met Dr. Esheter. When I found, I was very surprised. I don't know what to do in this case, because I can improve parameter of this, make it heavier. I want to make the same parameter, but durable. And I found his book in Lenin Library in Moscow. And I decided to call him, I don't know where he lived, just call for 09, like here, 311, right, whatever, where he lives. I just make up some, I thought maybe he's from Palma Institute, one of the best. He said, well, I will make an appointment in 2 weeks in 15 minutes. Well, in 2 weeks, Friday, I came to him. It was, like I remember right now, 4:15 p.m. And I came from him in 6 a.m. We stay all night studying. I brought all these devices. He was very surprised. He said, I never know about this field. But what happens? Look at this. Idea of, we use some of Malishev's formula, this formula. So all mechanism, like you might remember, people think they are plane mechanism, but they're not plane at all. Why they're not plane? Impossible to make parallel, absolutely parallel axis theoretically. Yes, practically no. If they're not absolutely parallel, they like this. If like this, they is three-dimensional mechanism, right? And how can you move? You have to use freedom of degrees of freedom of movement in this case. If you put here different kinematical pairs, if you remember in that mechanism they show they have kinematical pairs of fifth degree y because it have links and axis only can rotate, right? If you put, so from 6 minus 1, only one movement, you have the fifth degree according to classification of theory of robot mechanism. And if you put here all these elements, you put negative 2. So system is double statically undefined. If undefined, it's supposed to be broken. Who in the engineering part? You know what I'm talking about, right? Engineering part? It's fine. It's supposed to be broken by itself because this is not a mechanism. This is a firm statically not defined. What we did, we used structural synthesis. I changed these elements. And look at this beautiful situation. When you put the pairs of force degree, what is force? They have possibility to rotate and they have possibility to move. 6 minus 2 is 4. Dynamic kinematical pair of force degree. And we got mechanism. And this is mechanism. After that, I structured this mechanism, the structural synthesis, these different structural formulas. And after that, I created the first in the world guide knee or rocket mechanism, where you can move distances over there automatically for this. And this centroid of this, and this how it look like. And you see trajectory is much higher. It never have problem with moving your leg against the pavement. So based on this, centroid is also very important because I can play average point of centroid in the place of natural system, natural rotation of knee joint. So that's why the next step, we study all this trajectory and this all basic mechanism in the world. You see my mechanism, unfortunately it's in Russian, I didn't have time to translate today night, right? I did it. But anyway, I give idea. This is my mechanism. And this all mechanism in the world, but basically Autobot. This is company which exists from 18th or 19th century. So since you have chances to operate with link of these angles, you can make synthesis which you need to get rid. Plus, look at this. Another we have this pair which moves back and forth, and this our foot. This is our foot, and this our shin. Right, this part below knee. They have particular weight. What we accomplished? We accomplished balancing effect without any loads. Because we already have a load. Our shoes plus foot is more than 500 grams. And trajectory, if you make synthesis, it will be the same. So we trim this element finally. We get effect without this element, without load. So far so good. Moment inertia, you can make synthesis from parameter of moment inertia and from point of view trajectory for swing plates. After that, we studied this ground reaction to be sure that all is durable in all these kinematical pairs and compare with all this our police knee, we name it, guide knee mechanism with all existing mechanism, and compare with different in the world what we have. And this our the first pattern with guide knee mechanism. The first was like this. It's even next generation because here we have the pair is sphere of third class. It has rotation in any direction. Self-adjustment mechanism. If you make it not accurate, system stay this way, then decrease all these reactions in pairs. After I created this mechanism, this our pattern, we start producing in one of these plant semashka. It's made of military aluminum D16T, And this is from their catalog. I put it, make a picture of this by this pattern they're producing. And this is element of this pattern. Structural formula, you see this? It can move and it can rotate around this axis. This is real mechanism. It's not a static in the undefined system. If you go to next one, to slide, after that, I contact rocket space industry. And analogy of NASA is Energia, who created the first Gagarin on these rockets, right? And we produce, basically, I get this patent together with them, and we produce it, it can be producing for 30 years right now, more than 20. Titanium, nice technology, and this is patent related to this one. So this is the first part of new units. Meanwhile, one company contacted me. He worked with Werner von Braun, also in space industry, right, FAL2, and he was hydraulic. His name is Hans Mauer, and he created the first. When Nazis were defeated, he came to the United States, created a company. He still works with him, and created a company which designed absolutely great new unit. This is our device with high precision, German technology, which changed this viscosity during swing phase. In this case, gate becomes symmetrical. But their pattern, after World War, pattern more than 17 years passed, and pattern, we move from dipole to fipole, right? We use ferromagnetic liquid and field. And this our device with magnetic rheological liquid, where we don't use this complicated hydraulic stuff, but control of magnetic rheological is much more durable. And this example with magnetic rheological. The first magnetic rheological unit was created by us, this one, this our pattern. And what is good, in this case, we have this pair which goes back and forth. It's not supposed to create any extra mechanism, just connect to this pair, this magneto-rheological unit. The next one, using this, we get another patent, and we created a gym for diplomats, where instead of simple devices used in gym, this usually what you use either weight is linear element, right? Or sometimes you use very seldom use hydraulics in your gyms, but our muscle is non-linear element. You can feed muscle with force which is not natural to muscles. And this system is part of training devices, our patent, which easily control. Even we use EMG control. You get signal from muscles, and you decided to, let's put you this way, you decided to a little bit, how to say, cheating. Like you take a force, you make like this, right? And if you take EMG, in this case, you're not working, system goes automatically. And this system impossible. When you make this movement, system watching for EMG and change current in this current, magnetic field, you make this change parameter of magnetic liquid, and impossible. If you work to this, you overwork. Impossible to cheat if you it's not compatible even to trainer, because trainer can see this, and system study your muscles. It was easy for us because our institute created the first myoelectric hand, which control was built in EMG. So we study EMG, and many of my students study EMG in the depths. Okay, and this, I give example, this unit they produce in rocket space industry, a lot of different units by our patents. I only tell you about one because otherwise you're supposed to stay here up to tomorrow. And this is a company, rocket space industry, who created all this, this name is Korolev, right? Okay. But they know they produce, in addition, this is equipment to produce prosthetics. And many of our prosthetics and titanium they produce in this company. And I give example, rockets in space operation energy. We produce these units not only for grown up, we modify it for kids, and we create it for long stem. Long stem is a real big problem. When people get long stem after amputation, no place where you put knee. In this place is located part of your body. So based on centroid, we created such a mechanism in particular for long stem. So that's how it looks here. And this for ballerina, okay? This for long stem. And for kids, it's similar, only smaller. Smaller weight, since okay. Advantage. So I combine. Remember, we analyzed few different units. In this particular case, we combine all positive features of all main existing units. As a result, we increase the ideality. We trim extra links. There are no extra links for this element because we have movement vertical itself. Trim extra weight. We cut it out load because we have a foot instead of load, and that's the low knee part of this. Trim crank mechanism, but left his action. Ideal final result. Decrease negative effects and improve durability since it becomes mechanism not statical and defined firm. And this is part 2. Improved trajectory when you use structural synthesis, improved centroid, acceleration without extra weight, eliminated extra load I already made it from different, improved kinematic and dynamics, resources, application with dissipative elements. Why dissipative elements? Because of these magnetic elements, magnetic is dissipative elements. They are easy to connect to this. And it becomes absolutely simple. If you look at this, just minimum amount of elements, and it has all this function. So, for instance, do you remember how they name it? Gold housekeeper in the world, the best ever, it was Lafayette. Who remember this name? Okay, unfortunately he lost leg, vascular problems. And we put him this mechanism, and he got another prosthetic from Germany, and he used this one, guide knee mechanism. He told me, he gave me a lot of pictures of this. One of these I have in my archive with Pele. Another example, one, Tatiana Kuznetsova, she became world champion in world marathon in New York, 42 kilometers above knee amputation on these prosthetics. So it's very durable and nice in implementation. Okay. Next, this mechanism, it get gold medal in World Exhibition of Innovation. We teach new technologies in Brussels innovation. So it's not only this. I just telling about one of them. Many of them get the same. If you look on our hierarchy of structure, example one of this. Now, after that I moved to super system to hip joint. And based on this mechanism, you see this articulation of hip joint. And this actually, you can recognize this knee mechanism. Look, actually a rocket mechanism. For hip joint, this articulation is also produced and very easy to control. Okay. Next, using system operator, remember we move to future. You create the first about knee prosthetics with external source of energy. When person losing energy, we use a special battery and we give this energy to patient. And this is prosthetic to future with it's also our patent with external source of energy. And some examples After, in our institute, we created the first myoelectric hand in the world. We produced it, and this was the first international congress for myoelectric control in our institute. It was funny. Our professor got a lot of mails. It was article that if you use myoelectric control, you can do anything compared to mechanical prosthetics. And Professor Wittgenstein, he got a letter from a patient. He said, I never play on piano. If I use it, will I play it? If I use it with prosthetics. Okay, this one example. I published some research. I have more, actually about 2,000 publications. This one of 4-volume book. It's related where we put the theory of this hierarchy, and we study electrostimulation. This also. It's in Russian. I get a contract with Springer, but we don't have time to accomplish this. And one more thing. Remember at the beginning we analyzed the different field of Da Vinci. One of this was education. Once I learned how to use Google, isn't that all education I really need? So you're supposed to get wide education in different fields to create something meaningful. That's why anybody who be hired to my institute, they're supposed to pass TRIZ preliminary. 2 books they must read. Algorithm изобретения and creativity is science. If they don't answer questions, they don't hire. And since I was director of science of this biggest institute, all my team, they got preliminary education in TRIZ. And after that, when they came over there, we taught them TRIZ. I personally taught them TRIZ. My method, all the staff, they were all prepared. We created the best team in the world in this case. And you can create anything without knowledge of different fields. That's why to prepare smart people for our corporations, based on approach of Da Vinci, what he said, we created a center where we teach kids. We teach not, actually we teach kids not on trees. Basically, they get nice foundation in classical science, first of all. You can't be a TRIZ master or something without knowledge, basic of math, science, etc. 42 years ago, together with Professor Malutin, we created object-oriented approach, method of images for education. We created this center in Moscow, was very popular with our way of teaching physics. If you take 300 people, 300 of them pass complicated physics tests. And now we developed this method actually 43rd year, and here in different countries with my former students. In one of the center ways I like it, I teach kids in Sundays when I have time with my team. This is Farber Center. And you can Google this is Facebook. We even don't have site because it's so popular. But in Facebook we have Farber Center for Academic Success. I give you an example of this. So we give them a nice foundation. For instance, you remember Diffraction theory? All of you got education, right? And we teach Diffraction in 4th, 5th graders. I give example. Basic, from my point, is the most important to understand and develop analytical thinking skills. Not only this one, we have special system for teaching. It's just one example. And we teach them basic of algorithm, basic. For instance, this example for computer science. And, his name is Cameron. And he is a great person, and what we did, we prepared him, this is Cameron. He got to one of the best elite school of New York, Stuyvesant. After, without preparation, he got to St. Paul School, the third boarding school in the United States, not New York, without preparation. Every year he getting 65,000 scholarship. He already got about 300,000 scholarship. Every summer he come to us. Yeah, 65,000 every year. St. Paul School, you can Google this. Why he decided to choose St. Paul? He liked Harry Potter, and it was boarding school, right? He also wanted to go to boarding school. And now he got, we help him. And this, I give you another example. We take our 4th and 5th graders and give them, let's say, exponential equation. For comparison, this student from, I believe, Brooklyn Tech, right? And he is simultaneously solved the same equation. One of the best, very nice person. But this small kid, she solved much better after our preparations. She's in 4th and 5th grade. Look at this. You see this equation? Not a big deal, but 4th and 5th grade is very impressive. So definitely they become the strongest. So this method of education works, and this comparison of our sciences, right? Okay. Our student, let's say, one of the examples, we get perfect score in SAT and expect 2400, many of them, and definitely get the Ivy Leagues in this case. And we teach them, give them basic of TRIZ, and after they work. We made presentation of our methods in practically all countries of the world, many countries. And this will be next Congress Da Vinci in Florence. We also make presentation. I can make more back this week. It's for us very important for both of us, for me and for Dr. Ramanel, because we're working together on script of movie. We already finished 2 versions, and we move forward, right? We finished this practically, the first version, and it's related to the niche. This helps us to produce finally. So conclusion, my scientific career plan was implementing the Vinci model of diverse education. This served as inspiration for 55 years of a fascinating journey. I got diverse education in many projects and many Da Vinci fields. If you look at this, remember Ishikawa diagrams, each of these fishbone diagram, it has asterisks. Asterisk where I got education. So I got education, many of them, it's very helpful. I believe his vision, genius vision, is not random, it's very helpful for future. If you keep in mind like life strategy, it's very helpful. I got diverse education, get many projects. The experiment successfully proved the hypothesis and showed that Da Vinci's model of knowledge, combining his well-rounded in diverse roundness in diverse fields, not only provides synergetic effect of creativity, but also better understand the legacy of the dreams. So the team worked together with us, very nice. Many of them have few PhDs, many of them are former students. Coming together is the beginning. Keeping together is a progress. Working together is success. And I like this expression. And my favorite movie is Magnificent Seven. When everybody takes their own part and keep move forward. Remember this movie, right? My son? Yes, absolutely. Okay. Okay. Optimistic vision for experiment inspired by Leonardo da Vinci. We look forward with great optimism of this. And this is our company. This is my contact, and you can find us in Google. This is basically, I believe, it's it. Before to continue, just briefly, all our product, I show that we use fishbone diagram. You can see this a little bit small, but wherever even Dr. Klein and behind the scene, we use fishbone diagram for Albuvir Antican. What is Albuvir Antican? It's our new line of the first in the world dynamic drugs against of cancer. For instance,
antiviral.
Yes, it's antiviral. Albuvir anti-cancer. And Gemma, you heard today presentation. Remember, somebody asked what tools of TRIZ we use. We use all the same methods. Multi-drug resistant, we are going to explain if you're not tired enough. What polymyxin, etc., etc. So now, any questions? Thank you for attention.
Questions, guys?
Yes.
Is there plans to manufacture some of your prosthetics using 3D printing or additive manufacturing by another name?
Well, maybe in future, yes.
Maybe in future years.
But I like idea of 3D printing, and we discuss a lot with a friend of mine. It's his main part of this. But so far we use technology for rocket space industry with top level titanium, right, in this case. In future, yes.
Thank you.
Okay.
So,
Please give some more information about the conference in Italy next month.
Yes, I give example. Italy,
Is it language in English or in Italian language?
English.
English.
It's international conference. It's
How
people.
about the size of the conference?
Size, I don't know. When I came here, I don't know about size. When we had conferences in Australia in biotechnology, it was like about 5,000 people. You don't know in advance when it comes to this, right? But size is not very important, but not good. I like this small auditorium, but good quality. It's not about size. Okay? Yes.
well, I don't know what about you. For me, it was a brilliant, super lecture. Yeah, how to be creative, successful, and productive.
Thank you.
Thank you very much. I love you.
Thank you.
Some pictures.
Yes. Okay.
No cheese. Less cheese.
Prize, Altshuller Institute Best Practice Award. This award is presented to a personal company that has demonstrated the most outstanding leadership and significant results in the application of modern TRIZ methods. This includes organization and administration of such work. Usually, this award goes out on organization that use TRIZ in an excellent manner in a specific project improvement opportunity. And this year, this award is going to Dr.Boris Farber and his brilliant team. Держи сразу.
Ideal final result. I will put our presentation.